Everything that I do in Mathematica is going to be done in what's called a notebook. And those files, that when I save them, they're going to end in NB, okay, for notebook files. And I can create a new notebook either by clicking on this new document or by clicking on this arrow and then going to Notebook. And then a notebook comes up. So just then I paused the recording and expanded the window, and also I changed the default font sizes so they're a little bigger, but that's not something you should have to do on your own computer, so that's why I didn't include it in the video. First thing I want to show you in Mathematica is how to evaluate something. Say I type 2 plus 3. I can't evaluate it just by hitting return. That just brings me to a new line. If I want to evaluate it, I hold down Shift and hit return. And there we go, that got evaluated. The reason return without a shift does something else is because I want to be able to have multiple lines at once. So for example, here's 2 plus 3, here's 4 to the third power, and now if I hold down shift and hit return, you can see that both of those got evaluated, both the 2 plus 3 and the 4 to the third power. In MATLAB, we worked all the time with variables, and defining variables inside of Mathematica is very similar. For example, if I do a equals 6, then a, if I write, for example, a times 3 and evaluate it, then it's just like evaluating 6 times 3. Okay, if I write b times 3, that's something we couldn't do in MATLAB. I get 3 times b, just displayed in a different way, but it's still using the variable name b, because b didn't have a specific definition. I hadn't stored any value to it. And something really important, something that's going to help you error check when you're writing complicated code in Mathematica, is notice the difference between this a and this b. Difference is that this a is in black, and that's because it has a value stored in it, whereas this b is in blue because I haven't stored a value in it. So don't pay so much attention to the output line, pay attention to the input line like this one. And when you're writing your code, sometimes you'll make mistakes because secretly something is defined that you think is not defined. If I want to get rid of this a, okay, a has been defined as 6. If I want to get rid of it, I can type in clear and get used to using square brackets in Mathematica. So I do clear with a capital C, square bracket, a, and now I'm going to evaluate it. So notice that the a turned from black to blue after I evaluated that line. So it's like saying that the definition of it being 6 went away. So if I evaluate this a times 3 line again, I've put my cursor here and done shift return. Now it's 3a instead of 18, which it was before. These different blocks, for example, this block here, this is what's called a cell in Mathematica. And if I want to get rid of it, I can go over here to the right-hand side and click once on the very rightmost bracket, which groups the cell, and then I can hit delete after it's highlighted, and those go away. If I want to clear every variable that's defined in Mathematica, the way I can do that is go up to Evaluation, Quit Kernel, and Local. Okay, what that does is it will delete all values that have been stored in a variable name. So right now it's like Mathematica has stopped, and to get it started again, I can type in anything I want, like how about 1 plus 1, and evaluate it. And there we go, 1 plus 1 is 2. And I don't know if you can read this on the video, but here was line 9, line 7, line 8, and here it's back to line 1, or input line 1. So after I quit the kernel, the numbering started over. One thing that might surprise you is if I look at the number e in Mathematica and evaluate it, that's not some built-in number. That's not the usual number 2.718 ... from mathematics. And why is that? Well, it's related to a convention in Mathematica which says that the variables we define or the functions we define, they should all begin with a lowercase letter. The variables or functions that are predefined in Mathematica, those begin with a capital letter. So the intuition is right that there's some built-in constant e. It's just not written e with a lowercase letter. It's written e with an uppercase letter. And as a hint that it's predefined, notice that when I typed in capital E, it shows up in black, like it's already defined. Whereas if I type capital A, that shows up in blue. It's not already defined. So let's evaluate this capital E. Okay, it just gives me a formatted E. There's like a slight difference between the font for this E and the font for this E, but that's not very helpful. What if I want to see a decimal approximation for it? The way to do that in Mathematica, again using square brackets, is with capital N. Okay, and notice that it starts with a capital letter because it's a built-in function, just like this clear up here started with a capital letter. So let me look at this capital N bracket, capital E. And there's the decimal expansion for E. If I want to get more decimal digits, like let's get 8 decimal digits, there are more. And one of the cool things about Mathematica is it treats everything symbolically. And what that means is if you write something like, how about e cubed? Okay, it just leaves it as e cubed. It doesn't do any rounding until we tell it to. And so, for example, I can get a huge amount of decimal digits of accuracy here, and that's not something we could have done in MATLAB. In MATLAB, I think about 20 digits of accuracy is the most we could hope for. But here, there are 100,000 decimal digits of E. It just keeps on going. And if I want to hide this but not delete it, I showed you how to delete it earlier. I can hide it by double-clicking over here on the rightmost bracket. Okay, I double-clicked. It's still there. I can get it back by double-clicking again. But now it's not taking up all that space on the screen. And if I wanted to evaluate it without it getting printed, well, it's the exact same as in MATLAB. Put a semicolon after it and evaluate. Now it evaluated, but nothing got printed to the screen.